In this video, I'm going to demonstrate how to model a box string in the OpenRoads designer and also connecting the box strings to the inlets placed in the corridor. So in this DGN, I created a 2D DGN and then attached the corridor, the terrain, and also I attached a linear element indicating the center line for my box strings, and then this linear element also has an active profile, which I will use it as the top elevations for my corridor. The profile for this linear element, I jab it to my corridor surface so that eventually the top level of my box string's top slab will be at the level of the corridor surface. Now I will have to set up a feature definitions for my box string. First, I will make sure that I am in the drainage and utility workflow. Go to components, and then in the category, select prototype. In the prototype dialog, in the section of conduit, I will do a right click, new, and then rename this new prototype to be box string 450 mm. Double click it to assign the hydraulic analysis property for this box string. I will scroll down to the physical sections and then change the section type to be a box strip, and then input the box strip size. This is the minimum size for my box strings all along, and then it is used to carry out the hydraulic analysis. I can also assign the material. Then it is all the necessary component I need to set up this prototype for my box string. Next, besides for the hydraulic property, I also need to do other details for my box strings. For example, I will have to define other details such as the thickness. I will have to do it in the template because the visualizations for my box strings will be doing by the corridor modeling. So here in the component tab, in the change sections, I will select template and create template. I will open up the normal create template dialog just like what we did it in our corridor modeling. Go to file, open to open my drainage template library. In this library, as you can see, I have created a template in the size of 0.45 millimeters. So the inner box size in this template is 0.45 times 0.45, and then with a thickness of 0.1, so it's 100 millimeter. If you have other thickness, you will have to adjust it in the template. And then the other important point in my template is that my template is constrained so that I can control the height of my template with this GL point. It is on top of my top slab for this box string. When I test the point control on this point. When I apply a vertical point control to this point, as you can see, my template will string. It will go up and then keeping the thickness and then keeping the horizontal, the width. And then I will close this template. Now I will go to the Explorer. Go to Home and then select Explorer. And then I will also open up the property window. So in the Explorer, I will go to the OpenRoads sections. Expand Standard, expand my active DGN, and then expand Feature Definition. Going to the Conduit. Select the Stormwater category folder, and then new a Feature Definition in this folder. Call it the box string 450 millimeters. Select this new feature definitions. Go to the property to assign the hydraulic prototype. Select the box string prototype we just create, and then in the conduit sections over here, select the change template, and then because it is a stormwater pipe, I will recommend that we use the shape orientations of the inward. Okay. So here, I have the box string. Okay. So now I have finished with this feature definition. Okay, one more thing. Assign the symbology. So just choose from the symbology list if you have no preference. Choose the stormwater conduit. I will do it for both linear feature symbology and the solid symbology. Okay, and then now I'm going to place the conduit with this box string feature definitions. The location I'm going to place the conduit is over here. As you can see, I have already placed the manhole. I just used the layout tab, paste conduit, select the feature definitions for the box string, and then I can select my start node, select my end node, select my other start node, and then here at this location you see that I will have a band. So I will use the control button in my keyboard to place this band, and then to paste the next band, and then tap the control button again, connect it to my end node, so that here is a pipe with some band. After that, as you can see in the 3D view, I model it up a conduit. However, it is in a size what I defined it in the prototype. Now I will have to select these two conduits, and then from the property of these two conduits in the feature sections, there is one row say that the current setting for the change is no, so it is not creating the change at the moment. And then now I will say yes to these options, so that it will use the change template I defined for the feature definition to create the visualizations for this box string. Last step is to apply the point control to the GL point in my template. Remember, I just showed you in the template dialog, it is the top level on my top slab for my box string in the template. I will assign it to this linear element, the geometry element, so that the top of the slab is approaching to the corridor surface by using this linear element. So I will select my corridor, select both my corridor, try to do a right click in the property onto my corridor. I will have to do it, let me see if I can do it on both. No, I will have to do it one by one. So select my corridor, right click, and then corridor creation tools, and then I can select create point control. In the create point control setting box, first I will use the vertical mode, and then control type is a linear geometry. I will lock to start and not to end because I'm going to do it on the full length of my conduit. And then assign the point of GL for the point control. It is the point in the template, so accept all the settings. Then choose my linear element, accept it. Then you will see that updated in the 3D view. I will do it for the other conduit as well, the box string. Select this one, create the point control, and then select the point, accept, select this linear element, accept it, so that now, as you can see in my 3D view, the top of my conduit is approaching to the linear elements. I use it to apply the point control. So now I have finished up modeling this box string. Then I will have to model the inlet. For modeling the inlet bench from my box string, I will have to use the tools in the layout tab to place a lateral from my conduit from my box string. So select these tools, and then I will select a node feature definition, which is my curve inlet in the Singapore dataset, in the Singapore utility, the box, the enhanced drop inlet chamber as the node feature definitions. And then I will also have to select the conduit feature definition. I will use a concrete circular pipe with a size of 300 millimeters. Now I will have to select the reference element for the placement of my inlet, the node feature definition. I will select the reference element in my default 3D view over here. I will select the curved component on that corridor. As you can see, that is the component of my curve. I will select this one. Then I will select the conduit element. as you can see, I will next locate where that inlet should be located along the box string. So maybe I just place it in the middle over here, and then approximate it at the cut lines over here. So kind of like that, and then rotate it. Okay. We adjust the rotations here, and then I will zoom in to take a look if it places it on my curve. So here is more a better location for my inlet, and then I will look at it over here to see that it is on my curve, so it's okay. Then I will place my next inlet. Use place natural. Select my curve elements in the 3D view, and then select my box conduit to place it here maybe. And then we adjust the rotation and the locations with the manipulation tools. For the inlet, unfortunately, at this moment you will have to do it one by one to your cut lines. So that now here I got two inlets branching from my box string. And then as I rotate the 3D view a bit, you can see that this two inlet branching it from my box string. So that's it for modeling it, the box strings and the inlet to my corridor.